Hi guys, welcome to Digital Tech Join. In this video, we will learn about the solid software design principles. So what is a solid? Solid is a popular design principle for object-oriented programming software development. It provides with the guidelines for developer to design more stable, flexible, understandable, and maintainable software solution. During this video, we are going to understand each and every term of solid, and we will also explain the things with an example. So, what is the full form of solid? What does solid stand for? So, solid stands for S, Single Responsibility Principle, SRP. O stands for Open Closed Principle, OCP. L stands for Liskov Substitution Principle, LSP. I stands for Interface Segregation Principle, ISP. And D stands for Dependency Inversion Principle. I request all the developers and the software architect to understand this and make sure that you are aware of the solid and what the solid stands for. So we covered two things: what is solid, and second, what does the solid stand for. Now we will go to each and every principle of solid and understand the things with an example. So what is single responsibility principle? Single responsibility principle, SRP, is a design concept that at any given point the object in the object-oriented programming should be made for only one specific action. The principle intends to create object or class modular with the fewer difficulties arising from interdependency. Modular nature makes more reusable, easier to explain, understand and implement than the one that provides solutions for everything. So if you just elaborate this, if you have anything, a class which is performing multiple functions, multiple methods, then it becomes very difficult to manage that. So basically when you have a class which says employee details, then it should be able to, or employee class, it should be only able to service. You should design that employee class only for activities pertaining to the employees. Now let us elaborate this with an example in the next slide. So now on your left hand side there is an object called customer, and this customer has various methods like it can add new customer, update customer, delete and find customer. However, it also has one instance called log exception. Now in a traditional way without single responsibility principle, generally what will happen, developers will create an object, they will have one more object called log exception, and in the customer object they will create instance of log exception and try to call that. Also additionally, in the same class they will write the method to log the inception. So what is happening, log inception can be a common method, and this can be used in various other objects. Maybe you might have an object called orders, you might have an object called billing, and there all you will need to add this log exception, either the method or the class. Now if you look at the right hand side, the solution and the single responsibility principle states that your object, your class object, should be doing a specific action or specific methods, and it should be intended to do that. In this case, you see customer object is intended to do the addition, update, delete and find customer activities. And then we have a separate class now which says logger, which is log exception method. Now using this inversion of control, which we'll learn later in this slides, you can invoke this logger in your customer object, and that will service the intention to log if there is any exception. So this is how the single responsibility principle is intended to be, and this is how a developer need to design the class and objects. Next is the open close principle. So what is the open close principle? The principle states that software entities like classes, modules, functions, etc. should be open for extension and closed for modification of its source code. Let us explain this with an example. Let us understand this with an example. So now you have a class called shape which has a method called draw. Now this is the base class and this is the main entity class. Now similarly we have other class which says, okay, we need to also invoke the draw for classes like circle, square and rectangle, which means that the base class shape as a method called draw, and circle, square and rectangle, they implement this shape class and then they use the draw method. So circle, square and rectangle, they don't need to write additional code to draw that object. They can easily extend it from the class shape. So this is how the design states open for extension. For example, the class shape, the object shape is open for extension, and that is the reason the other objects like circle, square and rectangle are able to implement it. So this is the open close principle. Now let's go to Liskov Substitution Principle. So similar to open close principle, but with an added advantage. The principle defines that object of the superclass, that is a base class, shall be replaceable, that is override, with the object of subclass without breaking the application. Very simple. Now here we have a superclass called the vehicle, and this superclass vehicle has two methods called get speed and get fuel tank capacity. Now we have other class called the car and the bus, which actually implements the vehicle class, superclass. Now here the vehicle is a superclass and the class car and the bus is objects is a subclass. Now the car and the bus object implements vehicle. That means they can definitely use the get speed and get fuel tank capacity. Now car and the bus as a last, the third option as a different entity altogether. However, they are able to use the get speed and get fuel tank capacity of the base class, that is a vehicle, and they have the capability to override it. So car will definitely implement vehicle class, okay, and then it automatically implements the get speed, but here car can do minimum changes like a change that does not break the vehicle base class, superclass. So here you can use the advantage of overriding from the superclass that is called in the subclasses. So this is Liskov substitution principle. Now the subclass can override the superclass method and can partially make changes such that it does not break the application. Moving on, we go to the interface segregation principle. The principle defines that we should not force classes to implement interface that they don't use it. Simply put it this way, larger interfaces should be broken to smaller ones. I will explain this with a very simple example, and I'm sure you'll be able to relate it. If you look at the left hand side, there is an interface called iTravel mode, which has three methods: packaging, by air, by land. Now we implement a class called the Jet Airways, and then we implement iTravel mode. That means Jet Airways class need to implement packaging, by air and by land. Similarly, we have something called public class Honda City Travels, which provides facility to passengers to travel by land, and it also implements iTravel mode. In this case also, Honda City Travels need to implement packaging by land and by air. But if you notice, Jet Airways is an airline company and it only travels by air, but it has to use the by land method because we are implementing iTravel mode interface. And then we need to add additional, so that to avoid this, we need to add throw new exception, not implemented exception in Jet Airways as well as Honda City class. Now how do we avoid this? Now if you look at the right hand side, I have modified this entire structure. Now I have something called common. Now if you look at here, the common parameters or the method is packaging, which is used in while you travel by air or by you travel by land. So now we have an interface called iTravel mode bag, which uses packaging method. Then we have another two interfaces called iTravel mode air and iTravel mode by land. Now accordingly, I have created one more class called the Jet Airways, which we have, and this class implements iTravel mode bag and iTravel mode by air. It doesn't implement by land. So then it doesn't have to worry about the method called by travel by land. So this is how you need to structure so that your interfaces actually are used by the classes which actually needs it, and we don't need to forcefully let the class implement all the interface method that sometimes it does not require. I hope this example was very clear. So this is interface segregation principle. Now our last principle is dependency inversion principle. This principle states that high level modules should not depend on low level modules, and both should depend on abstraction. So this avoids coupling. So coupling means dependency between classes. This helps decouple the high level and low level modules, making it easier to change the low level code modules without affecting the high level ones. Let me show this with an example. And I have also released in my YouTube channel full-fledged examples on dependency injection which actually meets this principle. So let me come back to this section and then explain dependency inversion with an example. So if you look in the right hand side, you see there's a class called project calculator, and it implements a method called add operations and subtract operation, which is another two classes, and then it performs the operation as per the requirement. Now if you look at the right hand side class, there are two instance that is created in the project calculator. That means your project calculator, which is an high level subclass, that is high level classes, is dependent on your low level modules or classes like additions, operation and subtract operation. So this is not the principle that dependency inversion wants to be implemented. It actually violates this principle. Now in order to modify this, on your right hand side you see I have implemented the same structure keeping the dependency inversion principle. So now we have an interface called iCalculate, which does a calculation with some parameters. Then I have a class called addition, which implements iCalculate, which performs addition. Similarly, I have a class called subtraction, which implements iCalculate, and then it does a subtract number operation. Now in this case, you see both the class have common method called calculate. Okay, and now it both implements iCalculate interface. Now if you come to the main implementation, that is a super class, that is project calculator super class, it invokes iCalculate interface, and then when it does an addition, it passes the parameters and then invokes iCalculator.add number, which actually invokes the class addition. So here the interface in your superclass, the interface object is initiated, and according to the operation, that is add and calculate, it calls the required method of addition or subtraction. That means here in your superclass we have implemented abstraction, because the actual class and actual implementation is nowhere aware to the project calculator, and that is how we meet the dependency inversion principle. So guys, this is how I have displayed and explained you in a very simple example and terminology the entire solid principle. And in my channel I have other videos that talk about dependency injection using ASP.NET. Okay, you can go and watch it. Then I have something called repository pattern using ASP.NET. How do you implement repository pattern in your ASP.NET application? Then I have something called how do you create a distributed architect in your ASP.NET MVC project. And then finally I have something on API gateways and microservices. So these are the knowledge base tutorials that is already there in my channel, and I request everybody to go and watch it and increase your knowledge and get aware of this principle. These are very important to build a very stable and a flexible and a highly scalable application. So guys, I hope you like this video. Please do share my link with your friends, colleagues and family, and help us to grow our digital tech join channel, and like and comment all my videos. Thank you so much.